Hello everyone and welcome to this video about t-tests. T-tests are an essential tool in statistics which are used in majority of introductory courses on this subject. When to use a t-test? T-tests are used to compare the means of two groups, so not three, only two groups. So we want to compare these two groups and determine if there is a significant difference between them. So for example, we might be looking for a significant difference between weight in men and females, or for instance different GPAs among students of business and students of psychology. And if we have only these two groups, then we will use a t-test. But what about if we have the same group but measured multiple times? For instance, we have here advertising and money spent before an advertising and money spent after an advertising. In this context, we will still perform a t-test. However, we will not perform the independent sample or between subject t-test we did before, but we will perform a within subjects or paired samples t-test, in as much as our group, before it was like male and female, will always be the same. Can be males measured before and after, females before and after, or the advertising, so the money spent before or after the advertising. So it is still part of the t-test family in as much as we are comparing two groups, the mean of two groups, before and after. So it is still a t-test, but this time we do not have a grouping variable, meaning gender, meaning major, because it's the same group. So we will do just a comparison of the mean before something happened and after something happened. In Jamovi, we go again into t-tests, we'll go into paired sample t-tests, and this time we just put them together. As you can see, Jamovi will split them for you. So as you can see here, there's a small line which basically says what's the before and what's the after. So you cannot put more than two, otherwise you will have to do another kind of tests. So as usual, assumptions check, we check for the normality. Normality, it's not fine, but for the purpose of this video, we will still pretend that the normality is fine. Otherwise, we can just use a Wilcoxon rank test. But let's leave it like this. We can have them both, but let's leave it like this. So we do effect size, descriptives, and mean difference. So our hypothesis is that the advertising will increase the amount of money spent, obviously. So what do? First, we check normality, not normally distributed, and hence we should do a Wilcoxon rank test, but let's keep doing a student's test. So in Jamovi, in order to test this, we will have to click again on t-tests, go on paired sample t-test, which is another name for within subjects t-test, and we will have this tab over here. As you can see, we have a small line which will define which one is going to be our before term and our after term. In our case, we have it already, so before ADV and after ADV. So again, t-tests are actually quite robust. So there is most of the time not a need to check for normality, but we can still do it. So we will check normality, and in this case, it's not normally distributed. Again, in majority of introductory courses in statistics, you can just proceed this way with normal students t-test. However, if we want to be precise, since the data are not parametric, we should use a Wilcoxon rank. Now, we can leave it, but personally, I would recommend you to return on this later on. But again, you can just perform it as a normal t-test. So, we have, again, the effect size, descriptives, and mean difference. Now, let's check if our results are significant. Let's check if the advertising actually increased the amount of money spent. So we have that our P is actually significant. We have a P less than 0.001, so it's a very strong significance. We have a mean difference of minus 5.35, so that is actually what we want. And the effect size is 6.79, so it's quite a decent effect size. So what does this mean? Well, this means that there is a significant difference between the money spent before and the money spent after the advertising, and this is said by the P, but if wouldn't be for the mean difference, or if this confuses you, confuses me as well, you can just look at the descriptive table, so money spent before 40 and money spent after 46, you see that there was an increase. So in this case, if the hypothesis, in our case it was, it is that advertising will increase the money spent, then it is confirmed. If your hypothesis was that it will decrease the money spent, then of course it would not be confirmed, in as much as the money actually increased. And finally, we have the special instances of t-tests that I was mentioning before, of the between subjects or independent samples t-tests. Now, the procedure which we will have to follow is virtually the same, but if you remember, as I mentioned before, in case we do not have homogeneity of variances tested by the Levin test for homoscedasticity, in this case we should perform a Welch's test. It works exactly the same way as the student's t, so you will always have a p-value, you will always have an effect size. It's just more adjusted for unequal variances, but it works exactly the same. Whereas if our data is not parametric, so if we do not have a normality, meaning that the assumptions of Shapiro-Wilk has been violated, then we will have to use a Mann-Whitney U-test. Mann-Whitney U-test is again basically the same as a t-test when it comes for U and data interpretation. It is not when it comes to calculations, in as much as student's t is using and comparing means, whereas the Mann-Whitney, being the data non-parametric, is comparing medians. But otherwise, the interpretation, especially for your introductory courses in statistics, would be the same. So in summary, t-tests are an important statistical tool used to compare the means of two groups. They are mostly used, to be really honest, in introductory courses, in as much as in the real-world research you would rather use other tests like ANOVAs, which can handle more levels, in as much as t-tests are a bit more basic. But of course, if you are testing, for instance, drug versus no drug and you're doing some clinical trial, you can still use a t-test, right? So they are still like an important bedrock which will build your knowledge and better your knowledge of statistics when you will reach the point of doing ANOVAs. But they're still, like, very essential, but also quite easy. And hopefully, by following the steps outlined in this video, you can confidently perform t-test as well and interpret the result by yourself for both independent sample and paired sample t-tests, and also for their variations like the Mann-Whitney U-test and the Welch's t-test. Thank you for watching.